I'm Rene, and today I will talk about storage setup and also, which is not in the title, some benchmark numbers from LVM and ZFS, and all in preparation on how to set it up or how you could better set up your storage pools for LINSTOR and also then for CloudStack, because that's question which comes up more often from our customers. So how could they utilize the best performance in LINSTOR with their storage or NVMEs or whatever they have? First, about me. I'm a professional software engineer since 2005. Had a few companies before. I joined Linbit at 2014. I became a CloudStack committer 2024 because I did most of the work, or I wrote the LINSTOR plugin for CloudStack. And after some time, I guess they found it's okay to get me a committer. I'm from Austria, so as Linbit, the company, is also the headquarters in Vienna, and I'm living 40 kilometers south of Vienna. My hobbies are hiking, climbing, and paragliding, but I can't do that anymore that much because I have a 3-year-old son, so a lot of family time. So the agenda for the talk is, just while Niles was talking, I thought I will sneak in another slide here because I was so focused on LINSTOR and CloudStack that I forgot that maybe people are here that never heard of LINSTOR or don't know anything about it. So I sneaked in a short slide and tell you what it is about. And then some test results from LVM and ZFS, because that's also some topic that came up. Some customers of us reported that ZFS is very bad performing, and I wanted to prove that or check that out, and you will see the results afterwards. And then some pro and cons of different storage layouts which you could choose for LINSTOR, and then a theoretical guide on how to set up what we found a good practical solution for a storage setup and how that will look like. So what is LINSTOR? LINSTOR is a software-defined storage. It has, I'd say, the same architecture from technical stand like CloudStack. So you have the LINSTOR controller, which would be the CloudStack management server, and then you have LINSTOR satellites, which would be the CloudStack agents. But what does LINSTOR? LINSTOR orchestrates and carves out volumes from ZFS or LVM and puts DRBD on top of it. DRBD is also a technology developed by Linbit, which replicates block devices over the network. So it's like a RAID 1 on network level, but with multiple copies. So DRBD9 can have up to 32 replicas if you want to. So that's the short story of LINSTOR. Questions? Okay. So before I show you the numbers, first the warning. If you're going to set up a new cluster and want to choose the right storage technologies or LVM or ZFS, do your own testing. Also think about what you're testing. I had the same things when I started testing. My first numbers were very weird because I found out that I actually tested the NVMe controller more than the actual storage layer behind, because if you don't format the NVMe drives before every test run, as soon as the controller gets saturated or the internal memory cache is saturated, the numbers won't match anymore with continuous test results. And yeah, just the thing is, do your own testing basically before. Don't trust my numbers 100%. It's also dependent on hardware. So I don't know. The hardware we tested on is not the newest, but later more on that. So what is LVM-ZFS? So LVM is the logical volume manager. It's mostly developed now by Red Hat. It has RAID support, has snapshots. I put on Thin in parentheses because you can have also snapshots on LVM-Thick, but the performance will degrade a lot because on thick LVM, every write after you have a snapshot have to be done twice, or the more snapshots you have, the more writes you have. So only on Thin you will have this write on copy technology basically. And it has deduplication with VDO. VDO was, I think, first developed by some other company and then got bought by Red Hat and is now basically integrated into LVM. But also only in very recent versions, so with Alma Linux 9.5, you get support for VDO and deduplication on Thin volumes. So it's very recent to really use it. Then you have ZFS, so the zettabyte file system, which was originally developed by Solaris. It will probably never get into the Linux kernel, but there is this OpenZFS project which integrates it quite good. So you just put in the repositories and it's basically there. It is a volume manager plus the file system, so you can have CVOLs or the datasets which act as a file system. You have RAID support. Then you have additional data integrity, like checksumming your data. So as soon as you have ECC memory, I think you are fine or without worries about bit routing. Snapshots, then you have additional compression, deduplication, and encryption. But I heard some reports that the encryption is not that stable or shouldn't be trusted too much yet. So I saw some bug reports on the mailing on the GitHub. So the test setup is it's 8-year-old hardware, or even 10-year, I don't know. So the Supermicro Intel server, 96 GB RAM, and two rather older also Samsung SME 945 drives. I mean, by now you can have, I think, 10 times the random write IOPS. So it's not state-of-the-art hardware, but it is an NVMe. And the test configuration, so it was tested on Alma Linux 9.5. I did only block device tests. The NVMEs were formatted before each run, and these are the basic FIO settings. So IO depth 32, runtime 5 minutes, and numchops 12, and I ran these different block size tests. So here is the numbers. So this for 4K read. So on the left, the gray one is the bare metal, so just one single drive. Already surprising for me that ZFS was here faster with with the newer versions. That's probably ZFS had in the 2.3 release. So I tested 2 ZFS versions. In the 2.3.0 release, they made a lot of improvements on the direct IO path. There are still one pull request open, which according to the pull request, will triple the IOP numbers for writes because they don't use some queue for some operations. And yeah, I think the numbers would be a lot worse for ZFS if I even tested older ZFS versions, because I think in the last few iterations they improved the performance there. So that's the write, the read. So, and the write is very surprising for me, and I don't know, I ran the tests a few times, but LVM-Thin on a single drive is very bad behaving on 4K write. So maybe this writing of the metadata and the actual data is not very well queued. LVM2 stripes is in 4K the fastest here. Sorry, I have also to explain what these two columns are. Here, the last two columns are ZFS with STD C standard fast compression enabled. So I just wanted to show the numbers that the compression doesn't really take much of performance. So, yeah.
Sorry, can you explain the third bar, LVM-T2 stripes? Is it T for thin or thick?
Thin. The T is for thin, sorry, yeah. So it's always thin, because thick makes on the LINSTOR usage not much sense, because then you don't have snapshots, and usually you want to have snapshot support on CloudStack. Yeah, and this R0 means rate 0. So that's which would be the same as LVM2 stripes. So two striping means that two disks are used. These two columns, so this one is a single drive ZFS, okay. So a cpool on one drive, and this is on rate 0, so using two drives with compression enabled, and these are not. So this is 120K reads. I don't trust the numbers of ZFS here because they are twice as fast on as the bare metal drive on not rate, so there must be something wrong. I don't know why. So these numbers for ZFS I can't really trust. The others for the older ones look okay. And these are for the writes. Here, ZFS is actually double the performance of LVM on my tests for the newest version, so for 2.3.0.1. I also tested the same thing on 2.3.2 because this was released on this weekend, but the numbers were equal, so I didn't bother to change the presentation. And these are 8K reads. This is beneficial for, actually more beneficial for ZFS, because ZFS has a default CVOL block size of 8K, so it's basically matching. So I was expecting that ZFS is here performing very good. And it's also on the writes, so it's even faster than LVM2 stripe. And yeah, just so I have it in the presentation, because I guess you get the presentation shared anyways. Here are the results in IOPS as a table. You can look it up then at home or whatever. I mean, I can also share all my FIO results in detail if you're interested in. But anyway, I would still recommend, if you set up a cluster and you have to choose between LVM and ZFS, that you do your own testing in front, because it might be that really the latest NVMe hardware, which is 10 times faster than what I have tested with, is performing differently, because then things are 10 times faster, and then maybe there are other bottlenecks in ZFS which might create problems, and then LVM might be faster. So, yeah. Oh, sorry.
Do you have an idea why a LVM on a single drive performs so badly?
No, I don't know why it did that so bad on my test. I mean, the only thing is that they queue the metadata updates and the actual data writes badly or something like that, so they have to go on and on. I don't know. I can't really explain it for me. Maybe someone from you have an idea. But just I reran the test because I also couldn't believe it because it was really bad. I mean, compared to the others. So, and then as soon as you have a two-stripe, it was faster than ZFS. So it's very weird. So now I'm back to LINSTOR and how to set up a storage configuration. So what could you choose from? So you could use LVM-Thin and just create a big pool with all your disks in it with sequential allocations. That's one thing. I will come to the pro and cons in the next slides. Then you have the LVM-Thin and striped. So you can stripe either over all your drives or just groups of it. Then you could just use LVM-Thin as a RAID 10.1, 1.0. Then the other thing is you could ZFS, Thin or thick, because ZFS supports snapshots on both as stripe. Or you can't really use one big pool because it's automatically striping as soon as you create it. Then you have the same RAID options. And additional one, you have this RAID C, but you need at least 3 drives for that. So for the parity, it's like RAID 5 or RAID 6. I didn't test that. I guess performance will be worse because you have to write the parity bits. And so depends. I mean, if it's enough performance for you, then you can use it. Yes?
I'm not sure I really understand what is the advantage of having LVM write 10, ZFS write 10, or ZFS write Z when you're running Limbit storage, because the data protection is provided through across the nodes using Limbit. Is that correct?
This is correct. Yes.
You don't need a local protection of the data within the node. That's
correct. Yes, you don't need it, but sometimes the bad thing is, if you have a failure of a disk, you have to recreate the pool, and then you have to resync your whole data. So for some, this might be not a problem. For others, if you have really big pools, like, I don't know, hundreds of gigabytes or terabytes, and this happens, then you have to resync all the data through your network, and that puts stress on the network, and maybe you don't want that.
Okay, so in some deployments you have local data protection on the node and protection between the nodes for node level. Okay, thank you.
So yeah, that's basically the pros and cons I thought of. So LVM-Thin, you can have the largest possible volumes because you can have volumes as big as all of your drives. So if you have 5 drives with 3 terabytes, it's 15, then you could have 15 terabyte volume, a big one if you want to. The problem with that is if one disk of that fails, the whole pool is broken. So you can switch out the drive, but you then have to recreate the pool. And as just explained, you then have to resync all the data you just lost. And also the bad thing is with just so sequential allocation from LVM-Thin, you get only single drive performance because LVM will just fill the first drive and then go to the next and fill that one and then to the next. So there is no parallelization of writes. So that's why there is thin striping. So you could do the full. So if you have 5 drives and do a stripe about above all 5 drives. You still have the largest possible volumes. Then you have the most performance because it will stripe above all. And it's also the largest failure domain because if one drive fails, you still the whole pool is broken again, and you have to resync all the data, like larger DRBD resyncs. Then there's another option: is you can do it grouped. So if you have let's now say 6 drives, you could group them in 2 pairs. So you have a stripe over 2 drives. So then you have 3 pools with 2 drives in each, and this limits the size of the max volume. So then you could only have a max volume of 2 of the drives. So that would be in the 5 terabyte case, then 10 terabytes. But you have improved performance because it stripes at least over 2 drives or 3, how much you choose. You have smaller failure domains because of that, because if one drive fails, not the whole pool goes, just this one group. And that means you have then smaller DRBD resyncs. Now for redundant storage configurations, so if you have a RAID 10.1, you have a bit less performance and a waste of disk space, of course, because you have to local copy of it. But the advantage is you don't have any interruption if a disk, a little bit, you have the resilvering in RAID C and the repairing in LVM, but not like destroying the pool, recreating it, and resyncing the whole thing. So it's basically just putting the new storage disk in and wait until the recopying is done. And then there is this RAID C for ZFS. As I said before, you will have less performance because of the parity writes, but it's less wasted space, and it's extendable now with the latest ZFS versions, so you can add disks to the RAID C now if you think you need more space after some time. And do you have the advantage of uninterrupted operation. So and this would be now some sample configuration for a LINSTOR setup. So for larger setups, we would kind of missed the word now. No. Sorry. Yeah, let's say the best practice. Yeah, that's what I was looking for. So if you have a setup like with 18 4 terabyte disks, you would have 72 terabytes in complete storage capacity. Then you could split it up into 6 pools with 12 terabytes, which would be 3 disks each, or 3 NVMEs each. And we would just create 6 set of LVM-Thin pools, for example. Then each of them would be added to LINSTOR, and LINSTOR would handle the distribution of the volumes. So the default policy would be that it uses the one with the least allocated space, and just LINSTOR does this all for you. So and then you have a maximum volume size of the pool, so that would be 12 terabyte. And in the worst case, if one of those disks breaks, you would have, in the worst case, if this full pool, a 12 terabyte DRBD resync. Thank you.